So thank you for hosting this. So let's just go ahead and get started. I can see your screen. So welcome to everybody on our first webinar, Managing Water Stress for Superior Wine Quality. I wanted to introduce Mark Greenspan of Advanced Vit. Dr. Greenspan is widely recognized as one of the world authorities in terms of water stress management, or also I use the term kind of interchangeably with deficit irrigation, although I think we'd like to use the term water stress. So thank you, Mark. Thanks for making the time this morning, and thanks for actually sharing with us your experience. So,
yep.
Why don't we go? Go ahead. Sorry.
Yeah, no. I'm ready to go. If you're ready to go, I'll
okay.
Start.
So let's advance the slide and let's just get started with just a quick introduction. And my name is Christopher Dunnigan. I'm with Naviz Analytics. We're very proud of our new product, Invino. We'll be talking very little about that. Actually, today is mostly about water stress because that's what everyone signed up for. But if you could just advance the slide, Mark. Okay. So this is really what we're going to cover. Do you want to speak to this, Mark, in terms of the topics for discussion today?
Yeah, I'm happy to. And I might add, if for the people who are attending, if they could mute their mic, either on their microphone or on the screen, that'd be appreciated. So we don't, because we can hear background noise. So today I want to talk about water stress management. I like to use that term for wine grapes because deficit irrigation is a little bit fuzzy for a lot of people. A lot of people don't really understand what it means. Maybe if I get a chance to, I'll try to explain what I mean by that. But water stress management is really important for wine grapes, and it doesn't matter what level of quality you're aiming for. It's still important. I want to talk about what I like to borrow some terms from economics, supply and demand. But in this case, it means something completely different. Water supply being the soil reservoir and irrigation, and demand being the plant's demand for water, use of water, and stress. Talk about the technologies available on the plant side, and probably delve a little bit more in detail in the soil moisture side, because a lot of people understand the plant side, don't understand the soil moisture as well. And then we want to talk a little bit about how Invino fits in on their technology, this whole concept of water stress management in grapevines, any crop really, but grapevines specifically today. And
cool.
I'm guessing you want me to continue, right?
Yeah, let's keep moving through. And I think we just got a couple of housekeeping items. As Mark said, if you guys can mute out, just to make sure that we have any background noise. We do want you to be able to comment, and at the end we'll come back to a Q&A. And if you can't see the comments, there's a little bubble at the bottom of your screen. For those of you not familiar with WebEx, which is most of us, you can put comments in there or questions, and just address it to everybody. You should be able to see everything. So if you don't see the screen, or if you have any issues, just go ahead and put a comment in there. But we will have an offer at the end of the webinar. So please use the comments screen for any questions. I'll turn it back to Mark, and thank you everybody again.
Okay, I'm going to try to move through this fairly quickly because we're trying to get this through this and allow some questions at the end. But I have quite a bit of material in here, and I may have to skip through some of it more quickly than others, but there's definitely some concepts I'd like to get across. And this is really the crux of it. This little diagram that I put together several years ago, where we have the phenological stages shown at the bottom of the x-axis, from bud break through maturity, harvest. And then vine stress is on the y-axis, and very generically shown as just generic vine water stress. So the more stressed being towards that red, and then less stressed towards the green. So, and I get this from a lot of people. They say, "Well, I'm growing $12 bottle, I don't need to stress my vines, and I really disagree with pretty much all that. I'd say this applies to everybody, whether you're growing it for that eight to ten, $12 bottle of wine, or if you're growing it for $100 bottle of Cabernet. It really does apply. And if it applies to Chardonnay as well as it applies to Cabernet. It just applies slightly differently. So the pattern is going to be the same. The level intensity of stress is going to be different. So generally speaking, reds are going to have more stress applied to them. Generally speaking, higher quality wines or higher quality red wines are going to have more stress applied to them. Lower quality wines, less stress. That said, though, the general approach here is going to be the same for any wine grape, in my opinion. And the concepts are, and I'm going to try to get a pointer if I can. Get this pointer, there's my laser pointer. Between bud break and bloom, we don't want any stress. We don't want any stress during fruit set. That could be a disaster. So whether we're in a dry climate or a wet climate, our aim at that point is not to have vine stress. We want vines to leaf out. We want vines to grow vegetatively, and then during bloom and fruit set, we want no stress on the vine or very little stress on the vine. Now that changes after we have our fruit set locked in. Then we want to progressively increase stress, as I've kind of shown here in a rough diagram. So there's multiple reasons for this. The most obvious reason, or the most blatant reason, is to slow down the canopy growth, because we don't want the canopy to continue growing past. Well, definitely we don't want it to be growing past veraison, but we ideally like it to stop sometime before veraison. That said, we want to grow a good canopy, and then beyond that good canopy, whatever that means, I like to think that's roughly a 4 foot of shoot growth, and then we want it to stop. If we're having to trim our vines more than once, then that means we've probably most likely hit that target. So I have this little thing called the magic window I'm showing there, and that is a period of time where I'm shooting for the maximum stress. The window starts, and I didn't really show it really clearly here, but roughly around lag phase through veraison. What I mean by that is when the berries hit their roughly pea size, maybe a little after that, when they stop growing temporarily, which is not always really easy to identify. It's actually really difficult to identify. But roughly the lag phase is going to occur about 6 to 7 weeks after bloom, and the fruit's going to stop growing. That's actually an opportunity for us to apply stress and trigger a lot of biochemical activity within the plant that's driven by hormones and stress hormones specifically. So we really want that stress to be applied before we start seeing color or softening in the fruit. And I like that to be held through the end of veraison if possible. That means almost to the last berry turning color and softening. And then after that, we can relax the stress by adding a little extra water by irrigation. We want to maintain the leaf canopy. We want to maintain photosynthesis in the leaves, so we don't really necessarily want to maintain a high level of stress in the vine. We don't necessarily want it to go back down to where we were at fruit set, but we want to relax it from our maximum. And that's the general pattern I like to do. I'd like to impose in grapevines. And again, it applies regardless if you're growing a high end or a moderate end or a low end wine. It's still going to be the same process. It's just that our level of stress or intensity of stress is not going to be as high on in some cases. And if you're in a dry climate or a wet climate, it depends on whether you irrigate it, whether you don't irrigate. Lots of factors here, which we're not necessarily going to get into in depth. I'm going to get into just some of the basic level stuff here. And just for a little bit of background, most people know this, but some people still don't. And I like to make sure that everybody's on the same page, that grapevines or any plant really, almost any plant, any terrestrial plant is going to be moving water through it. And it's not that water's pushed through it. It's always under tension. So it's being sucked out of the vine, sucked out of the plant into the atmosphere. And what I mean by that is water. And water is sucked through the vascular system of the plant down to the roots and into the soil matrix where it's removed from the plant by the plant. That means we have lots of different things we could look at, starting from the soil. I guess some people say I'm hard to hear here. I don't know. I'm right against the microphone. I can't speak any louder. Um, might be a control here, but I can't get to it. So, Christopher, are you having trouble hearing me?
No, I can hear you, Mark. I can hear
Okay.
you fine. I think it's tough because everybody has individual controls, obviously, in addition to the ones that we're setting. So I'd say to
Okay.
anybody that has any difficulty hearing, make sure you turn your speaker volume up all the way. But it sounds like you've got decent quality. So keep going, Mark. Thanks.
Okay. I'll try to keep my voice up a little higher. It's hard when I'm just talking to myself, but I am get to the point where we're showing where we're understanding what we're looking at, because we're going to talk about soil moisture, we're going to talk about plant stress, and we're going to talk about transpiration a little bit. Stomatal conductance, stomatal resistance, and all those kind of things play a part in this whole continuum of water from the soil through the plant into the atmosphere. And we're measuring a few key things about it, and that's what we're calling plant stress and what we're calling soil moisture. And I'm going to talk about both those things today. What I like to do is, as I mentioned before, divide the system up into two: demand side, which is really the plant and the atmosphere, and then the supply side, which is the soil moisture and the soil moisture reservoir, if you will. And then I just kind of diagrammed it out that way because it makes it a little bit easier to talk about. I also wanted to emphasize that the demand side and the supply side are both extremely important components of the system. There are folks that only measure soil moisture, and there's folks that only measure plant stress. I used to be the one that only measured plant stress and thought that was sufficient. But in reality, it's not. I found that measuring the supply, the soil moisture, is as critical, perhaps more critical than measuring the plant stress. But um, they're both extremely important. So on the plant side, demand side, we can measure evaporative demand. We can measure the evaporative demand of the environment. The actual transpiration of the plant can be measured using sap flow. We can measure other things in the plant like leaf water potential, which you're probably familiar with. But the ones I've highlighted in yellow are the ones I deal with most. So stomatal conductance and water potential are the ones I deal with on a regular day-to-day basis. On the supply side or the soil moisture side, we can measure soil water content. We can measure matrix potential. Both those are aspects of soil moisture. Water content being how much water is in there, and the matrix potential being how hard is that water being held in the soil matrix. Um, and those all influence the plant. Um, again, I'm highlighting the ones I'm going to measure and talk about, at least today. But everything's important. Just have to focus on a few things today. Just briefly about plant stress, and a lot of people know this stuff already. Um, these are devices we commonly use, and we use them every day in the field. These two devices are very common, very popular, and for a long time. Especially the pressure chamber on the right was developed in the 60s, and it's measuring it's measuring water potential. Typically, I measure leaf water potential. Some people will bag the leaves ahead of time and measure stem water potential. That's largely an academic argument. To me, water potential is very easy to measure and very relatively quick to measure. So we measure leaf water potential.
What?
Question? Okay. Um, I'm going to ask people to please mute their mics unless there's a question. So the pressure chamber is one device. The perometer on the left is another device. That's also been around for a long time. I'd say decades, probably almost as long as the pressure chamber. But that particular device I'm showing here this is the device made by Decagon. Now the company's called Meter, but it's essentially the same device up in Washington. It's made up in Washington. We use this on a regular basis as well, and that's used to measure stomatal conductance. And that's something that people aren't quite as familiar with. So I'll just go through a couple steps in talking about that. I think most people in the audience know what stomatal conductance is or what stomata are. They're leaf pores. I think appreciate them as as what they is how many there are in a leaf. And that's why I have that chart in the right showing the stomatal density. Done by some researchers in Australia, and that's the number of stomata per square millimeter. And so roughly 200 stomata per square millimeter, which is quite dense if you ask me. If you think about these little stomata, these little pores in the leaf, in a grapevine leaf, there's a lot of them. So we're measuring how open or closed those stomata are. And the stomata open or closed based on lots of factors, environment being one of them, but water stress being another. And when the vines are water stressed, they will close or partially close their stomata and restrict water loss through the leaves. And that's something we can measure. And we measure it with that leaf barometer device I just showed you on that slide before. That device I really like because it's very easy to use. You can see that's me measuring a leaf with a barometer, holding it in my hand. It doesn't require much to lug a pressure bomb around. The pressure bomb is still a very useful tool, but the barometer is we like it because it's very portable. It's also very easy to use. It takes 30 seconds to make a measurement. We can do a bunch of leaves, which in fact isn't necessary because the one thing we found with the barometer is it's got a lot more variability in the measurements than the pressure bomb does. So we typically take 5 measurements and take an average of those 5 measurements when we are out in a vineyard block. I like to show this slide also because people really don't have a very good feel, especially with the the barometer and how it relates to the pressure bomb is much more well known, I think, as far as what people are looking for. People know what 13 bars, 14 bars mean. And here I've kind of illustrated that on a continuum. Kind of gave at least rudimentary scoring of what those numbers mean. And it means different things for different varieties. It also means different things for different, say, wine programs. But typically we're trying to get our vines to hit this 13, 14, 15 bar range before we hit that lag phase, or at the time of lag phase, to slow the vines down. But honestly, the Stomata Conductance is much more informative. And the reason I say that is because if Stomata Conductance is modulated by not only the environment but also by plant hormones, and plant hormones being primary one being abscisic acid, ABA, which is a stress hormone in a plant. And the ABA not only closes stomata, and it helps drop the leaves, which is something we don't want to see, but it also stimulates some of the ripening processes in the fruit, which is extremely important, especially in red grapes. And that's really the crux of why we're targeting that window of time. It's because that abscisic acid, ABA, is triggering some of the biochemical processes that affect ripening. And that carries on through the rest of the season. And so, but hitting that window is really important. If we hit that stress target at 18 Brix, we're not having the same effect as if we're having that stress applied prior to veraison. And so I've shown here a few things. These are not necessarily a one-to-one correspondence. The Stomata Conductance and leaf water potential are very different parameters, different things to measure in the plant. And while they may correlate slightly, they're not cause and effect. And so this correspondence should not be construed as a one-to-one correspondence. It's more or less they both occur. They both are associated with stress, and this is roughly how I like to see them, or how I like to name them. It turns out that the water use efficiency I've shown here is WUE, water use efficiency. The highest optimum water use efficiency falls roughly in this range of Stomata Conductance, around 100 to 175 or 150 millimoles per meter squared per second. Those are the units I'm showing down here. That's where the vines are able to transpire the least amount of water, but assimilate while assimilating a sufficient amount of carbon through photosynthesis. So this target range for that reason, but it's also a target reason for range for purposes of applying that stress. And so I use this as a guideline for target. And I've shown a box there for that goes around stomata conductance and leaf water potential, and that's just a rough guide for your target stress. The red one is for red varieties, and the green one is for white varieties. Again, this can be a fairly movable range, but that's my general idea of where I want the vines to be at stress level at that magic window that I stated prior to veraison. And that's, to me, that's very important. And that's really the crux of what we're doing with water stress management, is trying to get to that target for that period of time. And that period of time may only be 2 or 3 weeks, but it's important that we achieve that desired
I think
target.
so.
Okay, so this is just a quick diagram here of a pattern of leaf water potential. And I want you to look at that red line. And that's what we call pre-veraison deficit. Basically, in this case, we were irrigating it minimally to try to increase stress up towards veraison. And then after veraison, you can see that stress goes the other direction. So we're showing leaf water potential there in bars. Now, leaf water potential is usually expressed in negative numbers. So the higher the negative number, the more stressed. And you can see that red line is approximately what we're trying to do with most varieties. Especially red varieties, is drop that stress down and get the stress to a sufficient level, and then relax it after they start ripening. There's another treatment there where we have the blue line is receiving quite a bit of water and then being stressed towards harvest. That's another approach which I don't necessarily subscribe to. And that, for reference, that green line is just relatively giving the vines all the water they want. Now, this particular pattern is for Merlot. And Merlot is a variety we don't need to stress as much, or we actually don't want to stress as much as, like, say, a Cabernet Sauvignon, because Merlot is more sensitive to stress than Cabernet. And the benefits can be realized at a lower stress level. I like to throw this out here because I was asked to a long time ago, or a couple of years ago, to show some numbers. And these you don't have to write down because I think this recording is going to be available after this webinar, so you can always come back and look at it. And by this chart, I don't mean you have to do this. This is just a suggestion. I don't know your site, so don't hold me to these numbers. But a relative idea of where we want to be, and I like to look at this here because this is our lag phase target range, which is our stress window. And so, say, Chardonnay is going to be less stressed than a Cabernet, which is going to be more stressed than a Merlot. And a Pinot Noir, usually not quite as stressed also as a Cabernet Sauvignon. You can come back to these later if you want to look at them, but this just gives you an idea for both the pressure chamber numbers, which is in bars, and the stomata conductance, which is in these millimoles per meter squared per second unit. There's lots of other devices that can be used, and I've just shown a few of them here. Dendrometers measure shrinking and swelling of plant tissues, and they're shown here. This is one that measures the stem. That's not a grape, but that's not a tree. This is a grape petiole. That's where there's a dendrometer measuring the shrinking and swelling of the petiole. That can be used as a surrogate to some plant stress measurements the ones I just talked about. This is an infrared thermometer, which is a non-contact way to measure leaf temperature. That can also potentially work as a indicator of stress. And a couple devices here that are embedded into the trunk of the plant that measure they don't measure leaf water potential. They measure essentially trunk water potential. That's an exciting type of technology as well. Sap flow as well, which I'm not showing here, is another fairly common technology to measure plant stress. And I think at this moment I'm going to turn it over to Christopher again and talk a little bit about their technologies, and then I'll come back and talk about soil moisture.
Great. Okay. Well, thanks, Mark. I'm going to go ahead and share my screen now. And let's see here. Right thing. So what we're going to do is just take a quick tour, and I'm going to actually, let's see, let me get to the right point on our presentation. Just talking about the demo, but so thanks, Mark, for the background and the detail. It really helps me to understand in terms of, you know, what we're trying to measure, and the fact that I really like about your presentation is kind of the balancing of the supply and demand. You know, the realization that it's not just all about soil moisture, it's not all about, you know, demand and ET, but it's about kind of that complete picture. That's really what we're trying to show. And as a matter of fact, I'll just give you a little bit of a preview here. What Invino does, and our platform is really built for viticulture and for smart ag. We have a solution, a technical platform, which brings all your data together in one spot. But most importantly, it's an open platform. So as opposed to a lot of vendors out there, and a lot of solutions have evolved over the years where, you know, sensor companies put out analytics and everyone has kind of their own particular solution. We have the ability to accept and to integrate different data sources and to present it all in a single dashboard. And I'm just going to give you a really quick tour of that. This is not about Invino. I know most of you, virtually all of you, are interested in how to, you know, improve the quality of your fruit with stress management, water stress management. So I'll get right into it here. Go ahead and switch my screen. Can everybody see my screen right now, by the way?
No.
No?
No.
It's in a great
Let
screen.
me go ahead.
See your face.
Okay. Let me go ahead and
There you go.
okay, cool. So just really quickly, since you couldn't, I should have asked before, this is what I was, the screen. Can you see my screen now, this graphic? No. Stop sharing, let me. You know, I want to thank everybody and kind of just for your, well, thank you for your patience. We don't usually use WebEx, but Skype, which is our preferred tool, tends to be a little bit complicated sometimes for end users and for collaboration, so it's not always the most effective. Can you see a graphic now that shows, it says Invino?
Yes.
Okay, good. So this is what I was just explaining, and what I'm going to do is actually just show you a really quick introduction to Invino, but you can see all the different weathers or all the different data sources here on the left. What we built is an open platform, and it's really designed to allow you to put all your farm data, all your vineyard data in one place. And to the extent then that you are able to, you know, use this, not just monitoring the data, but also getting alerts and notification and setting up the criteria that basically notify you when you need to check something out or pay attention. It could be a soil moisture condition, it could be a weather related event like a heat event or any, you know, frost. There's a variety of different factors, but it's an open platform, and it's designed to work with both the tools that you have and the new tools and technology that you want to incorporate over time. So that was really our concept as far as Invino is concerned. And what I'm going to share now is the demo. So can everybody let me know if you can see my screen?
Yeah, I can see it.
So this is the Invino. Okay, this is the Invino application, and this is what it looks like. Portal. It's a cloud-based portal. Of course, we store all of our data in the cloud for reliability, security, privacy. We're built on the Azure platform, so everything that we do is to scale, and it's engineered with a very high degree of security and reliability. But this is just a quick overview to show visually what it looks like for a particular demo farm with different nodes, which really are here to the different sensors, and we can take this data not from just the sensors themselves, but from your vendor APIs. So whatever data is being collected, we report on it real time, and we have the ability then to present that to you and to give you a complete picture of the data. I'm not going to spend a lot of time on this application. It is designed, in essence, so that you can create the kinds of alerts and the notifications and the criteria based on your individual sensors and your individual requirements. We can bring in irrigation data, and one of the things that we don't really talk about a lot is we actually are also built on an AI platform. Again, Microsoft Azure AI, where we can take those raw data points and we can start to build them into recommendations based on an algorithm that, for example, in this case is based on disease prediction. The notifications can then be generated and sent out via SMS or email, but in essence, when conditions are passing a threshold or a boundary that you've set. But we can also, as I mentioned earlier, we can connect to many different sources. This is just a couple of examples right here. System that you are generating or that you're a customer of, in essence, that you have access to the data that they provide. We can go in and grab that data with a web service or an API, which is just a way to collect that information and present it in Invino. So if you've got 8 apps on your phone or a bunch on your desktop, we really have the ability to bring all of those sources together into one place and then present the information using the power of our data visualization tool to actually make sense of it. Let me know when you can see my screen refresh here with this report. Can you guys see?
Yeah. Yes.
Okay. So this is just a quick example of showing what Mark was just describing in terms of soil moisture, and I'm going to turn it back over to him now pretty quickly. But this is a preview of what you'll see Dr. Greenspan talk about as far as measuring soil moisture and how you do that. This is just quite simply irrigation data overlaid on soil moisture, and you can do it at a particular block level, at a particular average. There's all different ways that you can slice the data, but the point is we make the visualization easy to understand and easy to take action. You don't have to be a report developer. It's all built into the system. We're just taking advantage of the most advanced data visualization technology that's out there to take complex pieces of information and to make them simple to understand. That's really it. It's not there's no secret to it other than the fact that it's about really making things that are complex, simple, and easy to use. So you don't have to spend a lot of time being a report developer. You don't have to spend a lot of time configuring the system. It's easy to configure. It's easy to consume the data. It's easy to get the information out. So I think that's about all I'm going to do. I'm going to go ahead and I'm going to turn this back over to Mark. I'm sorry, to Dr. Greenspan. And if you could, Mark, if you want to go ahead and share your screen.
I will.
And take it back from here. I think we've got.
Okay. Are we back full screen?
We're back full screen.
All right, good. All right, I'm going to finish talking about, well, I'm pretty much done talking about plant stress. Now, I think plant stress is what we're trying to manipulate. I shouldn't say think. It is what we're trying to manipulate. But we're doing that by irrigation, by water management. Sometimes it means not irrigating, probably just as important as irrigating. And I like to do this with the aid of soil moisture. And if I can get my slide to advance, our business. now it's not advancing. So that means I may have to get out of this. Okay. I apologize. My computer's going really slowly. And I can't show my other slide. You've probably seen my presentation slide.
Yeah.
Okay. Let me do that. All right. Now we should be back in business. Okay, good. Anyway, I want to just, I don't think I really want to dwell on this much, but I don't know where our audience is. But it is very different to manage water in different regions. That's kind of goes without saying, but I want to just mention again, though, that the approach that we're taking for water stress management doesn't vary from location to location, but the way you manage that does vary from location to location. So here in the North Coast, California, we have wet winters and often wet springs. So that means we're usually starting the season off with a soil profile full of water. And our approach there is relatively simple. It's just not irrigate for as long as possible until we hit that target level of stress. A year like this, many of our vineyards didn't hit that target level stress until it was a little bit later than the period of time we wanted them to. Doesn't matter. We still take that general approach. You can do some other things like leave your cover crops growing a little longer, not tilling, removing some moisture that way. But generally speaking, what we're trying to do is get the moisture withdrawn from the soil as quickly as possible here in the North Coast. That's quite different from an arid climate like the Central Coast of California, like inland Washington, where you're going to need some irrigation early in the season, if not in the wintertime, to fill the profile full of moisture so the vines can grow relatively luxuriantly through fruit set, and then reducing irrigation after that, or even eliminating irrigation after that, to let the vines attain some level of stress. So the management is different, but the approach is really the same, or at least the goal is the same, and that is to provide that stress on the vine at that period of time. So irrigation scheduling, it's really only two things: how much and how often, volume of irrigation, interval between irrigation cycles. And so this is just a real dumb, simple slide showing that the lighter textured or gravelier soils have less water holding capacity, and so they can't be irrigated with heavy amounts of water. They have to be given small amounts of water, which means they're going to have to be given that small amount of water more often. Heavier textured soils can hold more water, and so you can apply more water to them, and because of that, they don't have to be irrigated as often. That's just something you usually know, I think, as a farmer. But the other hand, other way to look at it is, you don't necessarily want to irrigate big. I'm a small drink guy, and I like to put small amounts of water on my vines throughout the season if I'm irrigating at all. And that's because I think I have better control over the water stress doing it that way. That's a little bit of a side discussion we probably won't have time to discuss today, unless somebody wants to discuss it on the side. But the general approach is what I've laid out here. The more water holding capacity you have in your soil, the more you can put on, and the less often you have to put that irrigation on. Devices we use for soil moisture are really divided into two categories. On the left are soil matrix potential sensors. Those measure the water potential of the soil, or the water in the soil, or how tightly that water is held in the soil pore space. On the far left, bottom left, is the watermark sensor, and the other one there, here, I don't have my laser pointer here. I won't worry about it right now. But the other one here is a device made by Decagon. That's an older device, but they still have the similar type of device. The advantage of that Decagon one, or the meter, the meter device is got a much wider range of soil dryness, or soil wetness and dryness than the one on the far left. I don't use those sensors very much. They do have a definitely nice purpose. I use the ones on the right. So the ones on the right are water content sensors. One of the earlier ones developed was that little fork-looking thing, and I can't find my pointer. I really want to point at it. Oh, there it is. Laser pointer. Okay, so this type of device was developed. This is also a Decagon sensor, and again, Meter. The company's called Meter, but they still have this types of sensor. It's not this actual one, but this measures water content using something called capacitance. Don't have a lot of time to go into the technology, but this is forms the basis of a lot of water content sensors, including the one over here, which is a probe. And this is the type we use most often, pretty much exclusively, is this type of probe. This brand is called AquaCheck. We've used a couple different brands. We really like the AquaCheck probes. These probes have this kind of device embedded in this pole, and the pole has about 6 sensors in them. Intervals. My next slide shows it better, or my slide after the next one. But typically we use these in the field. These are buried in the ground, usually under emitters in the vine row. The most typical ones we use are these 4-foot long probes, which have sensors every 8 inches down the length of them, so we can measure not only soil moisture, but we can measure it at 6 different places in the profile. And often we attach them to some kind of node, and here we have an Envino node shown, but we ideally like to look at this in real time so we can hook this up to these devices and see them on platforms such as Envino. Just diagrammatically, this is the type of, this is a probe, and I'm showing the 6 sensors at various intervals, and this is our root system. It looks like lightning bolts, but it's really a root system. And the idea here with these sensors is they don't actually touch the water. This is encased in PVC or vinyl plastic, but they work by sensing it through an electric field. I don't have a lot of time to discuss it, but basically they're sensing the water content using this electric field. So it's a non-contact type of sensor. It's something, uses a principle called permittivity, which is something that's attached to capacitance. And the capacitance is affected by permittivity or dielectric constant, which is the property of the matter around or between the plates of a capacitor. So this thing will put a radio frequency signal on these plates and generate an electric field, and that's influenced by the surroundings. And the surroundings are either going to be, well, there's soil, and the soil, but really what we're looking at is pore space in the soil, and the pore space is either occupied by air or it's occupied by water. And water has a very different permittivity than does air. They're kind of on the polar opposites of the spectrum. So that gives us the ability to sense water content without actually touching the water. They're really good devices, and there's quite a few brands out there, but they all work on the same concept. I'm going to go through a few charts now, and these are kind of old charts, but I like them because they're easy to see in a presentation, but I've had to embellish them a little bit because some of the fonts are small. But this is sort of a general timeline of soil moisture, kind of what Christopher was showing, but not nearly as nice, where we have water content shown in the y-axis and time on the x-axis, and this is about, I think, a period about 4 weeks. What we're showing here is a series of irrigations. And each of these irrigations, you see this little spike in water content upward, followed by water depleting, extracted by the vines between irrigation events. And so one thing we can learn here, we can see here, is that when we irrigate, some of these are spiking, some of them aren't. Now, these different colors represent different depths. And quickly, the blue line here is 8 inches. The red line is 16 inches. The This magenta line here is 24, then 32 is this green line, and then two lower ones, 40 and 48 inches, are down here that you can see aren't spiking. So the water we're putting on is not percolating all the way down to those lower depths. It's percolating only partially down the profile. And for instance, here you see it spiking at this green line, which is 32 inches. But over here you see it's not. It's only percolating and spiking here at 24 inches. So you also see at this, you also see, I can't read now. You also see in this last irrigation, we irrigated here, and then the irrigation not only didn't percolate very deeply, but you also see that the moisture rose here. If we zoom in here, which we're not going to do right now, it a little bit delayed from this spike, and yeah, without getting into a lot more detail, I'm not showing you what I'm really seeing here is that the water is percolating down to about 16 inches and then re-wetting down to about 24 inches and slightly touching this 32. But I can really within about 4 inches tell you how far the water wetted each time we irrigate, so we can really be precise on our application. And that's really how we determine the volume of irrigation. It's how much does it take to wet that amount of profile that we want it to wet. It takes a little bit of iteration, but we can learn that pretty quickly. This is also really important. Now this is that same data I just showed you, but in this case it's a summation. I prefer to use average, but this is a summation. The software uses it basically sums up the water in the profile in one line. And this is really important to look at because I've already shown a couple reference lines here. This red line here is what I call the refill line. That's the point where we want to irrigate. And this upper line here is I call the full point. It really doesn't necessarily correspond to a classic wilting point or your field capacity, but so these are actually working numbers that we have to calibrate for each individual location that we're measuring. It's not difficult to do, and we do this in conjunction with plant stress. So when the vines get to a certain plant stress level, we kind of note where that soil moisture is, and that's pretty much where we draw our reference. The nice thing about that is that reference line tends to hold from year to year, so we only have to do this calibration really once in the lifetime of this device. But you can see here, every time we irrigate, water spikes. Each one of these dots is actually a half an hour. So it settles down, and then you'll notice these little stair steps. Those are important to note. That's not noise, that's actual real. Daytime, the vines transpire water, so the water is extracted. At nighttime, they don't transpire, so that you get this little flat spot. That's very diagnostic here. It's also very diagnostic in just the individual levels. You can see where these little ripples are actually roots taking up water during the day and releasing or not taking it up at night. So that can actually be very diagnostic on determining where your root system is active. But the important thing is here you can be very precise on your irrigations. This is pretty precise. You see we irrigated this one maybe a little prematurely. Maybe we could have gone another day or two. These are just weekly irrigations, but you can see that we've got it down to a certain amount of moisture applied, and that each time we're irrigating approximately the same moisture content as where we were before. In this case, there's going to be some variability due to the weather conditions. If it's hot, high ET, windy conditions, then we would have a different rate of drawdown, but we've got this on a kind of a regular spaced interval. And you can see that we're more or less keeping the moisture content stable over time. The other things to look at, this is a little bit more of a zoomed in, and it's not the same site, but this is also the total profile content, water content, where we've shown a longer duration between irrigations here, just to kind of illustrate the pattern that you typically see with irrigation events is that when we irrigate, initially the water is drawn down rather quickly, and then you see that it starts to flatten out between irrigations. This is important because that means this water here is easily extracted, the vines are not stressed, but as we get drier soil, the water is more difficult to extract, and you see this flattening out. And this maybe is something we want. Maybe we want this vine to struggle between irrigations. If so, then we're going to make that irrigation interval fairly long. You know, if we're growing like a Chardonnay or something we don't want to stress, Sauv Blanc maybe, then maybe we want to set our refill point much higher up, and then we can irrigate on that basis, and the vines don't struggle or stress as much between irrigations. But we can really manipulate the soil moisture here by knowing this. We can manipulate the water stress on the vine by knowing the soil moisture. I guess that's really what I'm trying to say. There's some term here that RAW is readily available water, and that's really what we're trying. It's kind of a fuzzy concept, but that's kind of this point where the water is easily extracted. It looks like about 1, 2, 3, maybe 4 days, and then it starts getting more difficult to extract as this curve starts flattening out. I like to show this chart also because it gives us a picture of watching the root system become active. And this is earlier in the season. This is a snapshot of about a month between, I think it's April through, no, sorry, it's May through middle of June. And it's showing what's basically unirrigated system where we've in a vineyard, where at this point this 8-inch depth is already fairly low, but you can see that this is a 16-inch. It starts becoming active and taking moisture up after the 8-inch. It's fairly dry, and then after that gets a little lower, than the next level steps up. You know, the 24-inch becomes active and starts taking that moisture. Then the 32, and eventually you can see over here that's the 40-inch, and you can even see here we're starting to wake up. You start seeing those little ripples in the moisture content, even at 48, and eventually that will start declining as well. So this is very useful, especially in the North Coast, where we're trying to get our growers not to irrigate so quickly, not so early, to let the vines get stressed. And if we show them that, and I show myself that the water content is pretty high down deep in the profile, and that the vines are going to get it, then we're usually willing to hold off and wait for that water to be extracted before we start irrigating. Because if that water's there in plentiful supply, we're not going to be able to get our vines stressed. The only way to do that is to let that moisture be extracted. Now, there are cases where the roots just simply won't get down there, and we see that quite often, especially in some shallower rooted rootstocks and some soil types. And in that case, we learn that we can't get that moisture out, that we have to start irrigating before those deeper depths are actually tapped into. Real quickly here, this is another diagram. This is the same kind of information. This is called the stacked view. I don't use this very often, but essentially we have the various water contents shown on top of each other in very small graphs. The nice thing here is you can see pictorially what happens during irrigation, where we irrigate and the water rises at progressively lower depths. And you can see by the time we start irrigating here, roughly that point, and the time it hit the 48-inch depth, it took about 3 hours. Now, that's just one particular case. It may take much longer than that, but in this particular case, it took that long. So we know if we irrigate more than 3 hours, we're probably going to push water past the root zone. In this case, it's a fairly shallow side, about 40 inches. But nevertheless, this applies to pretty much everything. We can use this tool as another way to look at that chart I showed you at the very beginning of the soil moisture discussion. And then I'm wrapping up here, but this is just this is a site we've been working with many years, since 2013. And this is just the average soil moisture. And we draw on this band here, and the band is really, again, to show just a different representation of the refill and full points. The first year we went there, we found we went a little too far. We stressed the vines too much. So we found that eventually we set that limit line a little bit higher than that first year. But this is full year. So this is 1, 2, 3, 4, 5. Every time the water spikes up here, that's actually a full winter rainfall. And then letting it dry down until we hit that point roughly again. And you can see that it provides a fairly reliable indicator of when we can irrigate this vineyard going forward. We can almost stop doing the pressure bomb in these vineyards because we have this reliable device in our soil, and we can use this target level year in, year out. Well, we have it running here, but I'm not showing the 2019's data. The last thing I want to really talk about is we talk about deficit irrigation a lot, and people always go back to ET, evapotranspiration, and and most people, there are some other technologies that are better for measuring ET, but the common way, or the most common way, is to use the reference ET equation developed a long time ago, the Penman equation, and that's just what I want to show here. We've adopted using soil moisture, and I irrigate a lot less than almost anybody I know. And I found that that's perfectly fine. We can irrigate our vines and not have excessive stress and leaf loss. And I still irrigate a lot less than so many of my counterparts. And this is just a good example of one time I bothered to out. So here is an average soil moisture in a vineyard. This is in south part of Napa. We irrigated, let it dry down, irrigated, let it dry down, irrigated. So I wanted to see this period of time from here to here, where we put on 2 irrigations, or the grower did, ended up putting on 2 irrigations of I think 6 hours or 6 gallons per vine. So it's 12 gallons applied between this point and that point. I calculated the ET based on the weather station. I applied a crop coefficient, which I don't have time to go into right now, but a lot of you know what crop coefficient is. Simply a multiplier of reference ET to get to crop ET, in our case, a grape crop. It's roughly 2.21 inches during that period of time, which equates to 66 gallons per vine. I put on 12 gallons, and if you take that ratio, we come up with about 18% of crop ET. And I've done this in other places. This is my presentation one, but I've done this in other times. I've looked at it. I usually come up between 18 and 22% of crop ET. So when people are telling me they're deficit irrigating and they're irrigating at 60% of crop ET, I say, well, you're probably not deficit irrigation. I'm sorry, deficit irrigating. You're probably not at all deficit irrigating. And that's why I really got I really fell in love with these probes and these devices to measure soil moisture, because they can get us to irrigate so little and still get full crop production out of them. Our system. I think I only have 1 or 2 more slides. This might be my last one. I like to use this one when I give talks to classes, because I get to quiz the students on what they think is happening here. Today I won't do that. But here we have a grower. We installed a probe, and they started irrigating, and I noticed these things were happening. If you see this, these are spikes from irrigations. This orange line, focus on the orange line. The orange line is the 48-inch depth. You see how it goes up to about 92, 93, and flattens out, and then drops down. What's happening here is they're irrigating excessively, and the water is basically saturating. So the soil is saturated with water here during the irrigation, and actually for several days afterwards. I told the grower was irrigating too much. Eventually, and maybe not even during this time period, he got the message. But it's actually very difficult for people to realize how much they're irrigating if they don't really see it. And this is a good picture of excessive irrigation. Chris, I think you probably want me to wrap up. I always forget how many slides I have here.
Yeah, I think we're definitely getting up against time, and I know Chad had a question. I wanted to open it up and allow everybody to unmute. So if you could just kind of wrap, and then we'll get to the Q&A. I think the Q&A placeholder here.
Absolutely. I got a couple slides here, which I think I'll skip. It's essentially showing 2 different locations. One where we had shallow soils, rocky soils. We had to irrigate small and frequent, as you can see here. And then another site where we had a deep, very uniform soil, which we could irrigate deeply, and we only had to irrigate once a week. And that's basically showing you adapting the irrigation practice based on the location, the soil at that location. This is a recap, which I don't think we need to necessarily go through, but if you want to look at this talk later, I'll leave this up here just for a minute. But the idea here is that we want to stress the vines. We have a prescription, more or less. I hate to call it a recipe, but it is a general pattern we want to follow in most of our wine grapes, and that can be modified based on your variety, based on your location, and based on your target wine program, and of course price, quality target. But the general pattern's the same. The management's can be different based on your soil, based on your location, climate. All those kind of factors change, but really the whole pattern is the same. We want to use the plant stress measurements to verify that and to really guide our stress, plant stress, but we want to use the soil moisture to help guide our irrigation. And that may simply mean not irrigating, but also to just know what's happening below the ground. To me, you have to know both. You have to know above ground and below ground. It's that supply demand kind of thing, and I think that's really important. That's what I wanted to get across today, and hopefully at least got your thinking about it. I guess we have time for Q&A. So
yeah, and so well, thank you, Mark. This has been, you know, I could listen to this for hours. I'm so interested because I think that one of the things that we took away early on, we started working with Dr. Greenspan early on, was that what you think and what's really happening when you start to ground truth and really look at the data, it may not be as it seems, obviously, and I know I'm kind of stating the obvious there, but it's always interesting to me when we can take the data and really kind of look, you know, an X-ray of what's happening below ground and really what's driving plant health. But I wanted to get back. Chad has a great question here, and I just wanted to ask everybody to unmute if you could. I want to thank you all for staying muted so the background noise is good, but I'd love to open it up for questions, and because we don't have too many people on here, I think we've got about folks, so if you want to unmute your phones. Chad, do you want to go ahead and ask that, or do you want us to just add a question in the chat window? Chad, are you there?
He said he wants to use the chat window.
Okay.
Did you type it in? I didn't get a chance to see it. The question.
Yeah, so Chad asked, you mentioned that water stress is useful at Verasion for all types of wine qualities. Can you explain why?
Yeah, well, and the reason is it's really about two things. One is slowing down the canopy growth, and there's really no any system or any program of wine that you want the vines to be growing past verasion. So if that in that simple context, you know, it almost doesn't matter about anything else. You just want the vines to stop growing, and the way to get them to stop growing is by applying a certain amount of water stress. So the vines are going to slow down. They're growing roughly around anywhere between 10 and 12 bars of leaf water potential. That's typically when they slow down. If they're still at 8 bars and 9 bars, they're going to continue to grow. And you don't want the vines to be elongating, the shoots to be elongating during ripening. That's diverting carbohydrates away from the fruit. It's also potentially causing undesirable wine quality attributes. The more technical, the more detailed reason we want to stress the vines is because there is an effect of that ABA, that stress hormone, on fruit ripening directly, well, sort of directly. The ABA will induce the expression of enzymes that are involved with the secondary metabolism of the grape. And the period of time they're most active in doing that is the period prior to and through verasion. That's why we want to apply the stress at that particular time, and that's it's really critical. And we have found by doing this for many years, the goal we've been trying to do, and a lot of wineries have been trying to do, and they're kind of achieving it now, is to get that ripeness at without having to wait for 28, 29 bricks. And this is a good tool to achieve that. We get the mechanism set up prior to ripening, and we do that partially through water stress management. We're finding that we're getting phenolic ripeness at a lower bricks, and I think that's been a real success for a lot of wineries now.
Chris, can you hear? Yeah, Chris, can you hear me? It's Jim Holmes. Hey, I'm way up here in the Northwest, in Eastern Washington. We've been doing a lot of work on the correlating stormwater potential with soil moisture. And one of the things that perplexes us a bit is the variations that you get if you just use the sum of moisture or the average, whatever. And so we've done some work using artificial intelligence to try to reduce that scatter, and it's worked very well. The problem is, don't know what to do with it after I get it. Could you think we could, in your side of the world, add something like an AI program? The one in particular we're using is artificial neural networks in R. So we use that to calculate what we should irrigate, and then feed that back to our system and turn our valves on and off. Do you think we could do something like that?
Yeah. Yeah. So when it comes to integrating soil moisture numbers and automating, let's say, an irrigation activity, that is something which is already being done by some of the growers. But what needs to be done beforehand is to first understand how, as Mark has shown, right, whether soil moisture is actually going to the correct depths or not, and what should be the variation at which the water should be irrigated. And yeah, and that certainly can be done. And there are growers who are already doing that.
We're looking at the whole profile, and that is not using the average when we go to the artificial neural network, and the results are greatly improved. But what I wanted to question is, could we put that through your system and use it for a control for our valves?
I'm sorry, James, I lost you there. No, I couldn't hear James at the end. So, Chris, if you could just translate that for me.
Exactly. That's exactly what I'm. Yeah, exactly. Yeah, the AI engine is fairly complex. That's why I was wondering if it was an issue that could be dealt with.
So that certainly can be done. So usually what we do is the AI models that even we build, we usually work with the customer on what is the patterns that they usually follow. And when it comes to AI, it is usually an iteration which is done. Some back and forth which is done before we conclude on, okay, that this is the pattern that should be followed.
Yes, so, yes, we would have the model developed and just feed in raw data.
Yes. Yeah, so certainly that can be done, yes.
Thank you.
Yeah, there's one more about NDVI. So let me just take a part of it at least. So when it comes to NDVI, yes, so technology is useful for understanding the soil moisture of the entire canopy, right? Overall, are there any gaps in, let's say, at certain places in the block, right? Based on the color variation, you would know that, okay, that maybe I have to adjust my irrigation. It could be there could be some slope, or it could be that the drip irrigation has some kind of problem at specific area. So yeah, definitely for soil moisturing, it is helpful. And stress, I leave that to Chris or Mark to answer that.
Bye-bye.